All right, so we're picking up on annuities. So now we're not talking about a single sum. We're looking at a series of cash flows that are all the same. So some examples would be your car payment, your house payment, lease payments on equipment, interest payments on bond is really where we're going to use this concept a lot because bonds actually have two different cash flows. They actually have the present value of $1. That's the principal that gets paid back at the end of the term. And then the present value of an ordinary annuity. Okay. Ordinary just means it payment for the cash occurs at the end of each period. So I'll jump over here. What did they say? To our present value tables. Trying to get that back in order. There we go. Okay. So come back up here. We have we let's talk about an ordinary one first. Future value of an ordinary annuity. I really like these tables too because they actually have the formulas on them. So it's a nice little backup. I'll get you a copy of these when you take your test and one that you can just have. If you're in financial management right now, you probably already have one of these. Okay. So future value of an ordinary. Ordinary just means the payment was at the end of the period. An annuity due just means that the payment is at the end, I'm sorry, at the beginning of the period. Okay. And the big difference is because an annuity due will get one more interest payment. Okay, one more period to earn interest on that. So it starts earning immediately. Okay, ordinary doesn't start earning anything until that cash payment goes in at the end of the period. Okay, so let's look at an ordinary annuity. They have an installment of note payable may require the debtor to make three equal annual payments with payments due at the end of each year. Okay, so an annuity due would start at the beginning, starts right today. Okay, and in this case, you'd have to make that first payment today. This would be really good if you're on the side where you're paying it back because there's pretty much no interest going to accrue on that one. Okay. If you are putting money in, this is really great too because you're going to put that money in today and it's going to earn interest from here to the end of that first year, whereas the ordinary one doesn't start earning any interest until after the end of year one or period one. Okay. All right. I kind of skipped past these. Y'all can go back and look at those concept checks on your PowerPoint. Okay. So now let's look at the future value of an ordinary annuity. Okay. Future value of ordinary annuity. Ordinary means end of the period. Okay. End of the period for the first payment. Okay. So they say, suppose you want to accumulate a sum of money to pay for graduate school rather than investing a single amount today that will grow to a future value, you decide to invest $10,000 a year over the next 3 years in an investment paying you 10% interest compounded annually. You decide to make the first payment to the account 1 year from today at the end of the first period. That terminology right there, 1 year from today, that is what clues you in. That's an ordinary annuity. Okay. How much will you accumulate in the account by the end of year three? Okay. Well, here we can go through this calculation, but we don't really want to do that. That's a lot of work. Okay. So your 10%, your first payment is 10,000 multiplied times 1.21. Okay. Because All right. We don't want to do that. Okay. Or we can go to the table and we can find 3 years where it intersects at 10%. Okay. And find out that this is going to yield us a future value of $33,100. Let's jump over really quick to that TI-84 calculator that I have pulled up. Okay. All right. Number of years, we're going to put 3 in there. Still 10%. We don't know the present value, and they're not asking us for the present value. Okay. They are telling us the payment is 10,000 a year. Grab that, go ahead and put that negative sign in there because one of them, if you've got a payment and a future value, one of them has to be a negative. So we're going to put 0 in for that one. 3 years, 10%. We're not looking for present value, so make sure you zero that out. That's just a little technical thing. All right, then we're going to calculate, find the future value. We're going to hit alpha, enter. We get $33,100. Exact same thing that we got over here from using the tables. Okay, and if we went through the manual calculation, we would do that as well. Okay, all right. So now let's look at the future value of an annuity due. So suppose that we're going to invest 10,000 a year over the next 3 years, but we're going to do it on the first day, the very first day. Okay. We're getting one extra interest period. Okay. So we've got 10%. And we're still at 3 years. So sometimes I like to just draw some of these little things out so I know what I'm looking for and it makes it easier. So 10,000 is the payment and it is an annuity due. All right. So we're not going to do the manual calculation. You can, if you want to pause the video right there and do it, you're welcome to it. Well, let's just see. They just did the manual calculation. They didn't actually do it with the tables or anything. So I guess we're going to do that. So let's go over here and we are going to look at future value of an annuity due. That's our very first one. We have 10%, 3 periods. And we grabbed that factor 3.64. 3.6410. Okay, that's the factor I need. So I'm going to come back over here. We're going to take where they've already calculated it, and the factor, we'll take the 10,000 multiplied times 3.6410. I put it in my calculator on my phone. Multiply that out, and you get 36,410. Notice these factors only go out so far on decimal places, so if you've got big numbers, you really need to be using the calculator. Is that close to what they had? That is exactly what they got. Because basically, when they were doing this right here, they're calculating that factor. Okay, let's come over here and let's look at the calculator. Okay, so we still got 3 years, 10%. 10,000. Let's zero out that future value. And then we're going to come down here and you see where it says payment end. It defaults to end because that's an ordinary annuity. We are going to hit it to beginning to make it annuity due. And we will hit alpha, enter, and that's the exact same number that we got with our calculator and with the table. Okay, so those are all the same. I'm just really showing you a lot of different ways that you can go about solving these. And hey, it's great. If you got 2 different ways you can solve it, do both. That way you make sure you get it right on the test. Okay, so there's that. They have several of these little concept checks that I'm not going to spend any time on. Okay, Let's come down here and let's do present value of an ordinary annuity. Present value of an ordinary annuity. Ordinary still means the exact same thing. Beginning of the period, not the end. Annuity due would be the end. Sorry, you hear me flipping pages so I can see my notes. Okay. And we would use, let's go over here, and we would have our present value of an ordinary annuity. Now look at that formula right there. None of us really want to do that, do we? I mean, we like numbers and we like math and accounting, but we don't like it that much. Okay. So I'm back down here. It scrolled me back up. All right. So suppose you want to determine the cost today of a 3-year graduate program. The programs cost 10,000 each year. That's our present value. Okay. I'm sorry, that's not our present value. I think we're looking for a present value. I'm so sorry. The payments are made at the end. N tells us ordinary. We're going to use 10% and it's 3 years. So our N will be equal to 3 and our I will be equal to 10%. Okay. Let's hope they do it manually. I think they're going in and finding these factors for each one. That's a lot of work too. Okay. So find the 10%, 3 periods, multiply by that factor 2.4868, and you should get pretty much the same thing they got, 24,869. Okay. Let's go over here to our calculator and do it really quick there. I am going to make sure I go back down here and I hit ending because I want to make sure that I'm getting the right numbers. Okay. We're going to look for the present value. We know the payment's 10,000. Let's zero out that future value. Okay. We're going to do alpha, enter, and that gives us 24,868. There we go. There, tiny bit of rounding right there. Probably the calculator is a better number than with the tables because sometimes the tables don't go out quite as far as they should in decimal places. Okay. All right. Now let's make sure. Let's try this as an annuity due. Annuity due, beginning of each period. Anytime you see beginning, you know it's going to have annuity due. Okay. So we now have $10,000 payment. Our N is still 3. Our I is still 10%. Okay. Let's go back over here. Well, let's see what they did. They calculated 27,355. You could get the factor, take that factor, multiply that out, and you would end up with 27,355. Let's go over here and let's zero out our present value. We still have our negative 10,000. We're going to hit beginning of the period and then alpha enter for our present value. We get 27,355. Okay. 27,355. Okay. All right. Now let's look at today you're considering acquiring an investment that will provide 3 equal payments each other the end of 3 consecutive years. However, the first payment is not expected until 3 years from now. The time value of money is 10%. How much would you be willing to pay for this investment? So, oh my goodness, we got like 2 different things going on here. Okay. So you've got to have the present, you're looking for the present value of 1, but we first got to back it up and figure out how much this string of these 3 payments are. What is the value right there? Then we'll back it up another 2 years. Okay. So this is a deferred annuity. Okay. So just like I told you, we're looking at those 3 dates. or those three payments, and we can, they did not make us go find a factor. Um, let's do it anyway. Present value of, and it said in, so we know it's annuity due. I'm sorry, ordinary annuity. We have 3 and 10, is that correct? 2.486. So I stopped the video real quick because this is a little confusing. So I don't want to look at that because that's combining two different things together. And I kind of want to show you how we do two separate calculations here. Okay. So we had that timeline, and this was 5, 4, and 3. We were trying to get that present value right there at that year 2, and then we had 1. So we're trying to find that. Okay, we can go to the time value of money tables. Right there, you see that point, or that 2.48685, and then multiply that times the 10,000 gives us a present value of 24,869. Okay, that just backs it up to right here. Now we got to go back 2 more years. Okay, now we're going to look at N is equal to 2 and I is equal to 10%, but there's no payments, so we're going to look at the present value of 1. Sorry about that. I'm trying to get over to the time value tables. There we go. Present value of 1. We'll look at 10% and 2. Come all the way across. Discount that back to 0.28645. And then we're going to multiply that times that 24,869. And then that would give us a present value. Oh, there's that factor of 20,552. What does that mean? You would be willing to pay $20,552 to receive a $10,000 payment starting 2 years from now for 3 years. Okay. So that's how you have to do that. Timelines are your friend when you're doing time value of money. Just in case you get a little confused, it's easy to read the timeline and make sure that you're doing the right thing. Okay. All right. We have a little concept check there. Let's see. All right, I think I'm going to stop the video and I will pick up on this slide in the next video.